I like to call this strange planes and straight lines. What we're going to do is take a look at how having lines on flat surfaces is different from having lines on spherical surfaces. Now, in July 2014, the crash of Malaysian Airlines MH17 was all over the news, and it was shot down over the Ukraine. Looking at the map here, you might wonder, what was it doing over the Ukraine? It started in Amsterdam and it's trying to go to Kuala Lumpur. So take a moment and use the map to come up with some reasons why the plane should or should not have been flying over the Ukraine. Now, you probably thought, okay, if I'm going to take the shortest distance, I should take a straight line, and that doesn't look very straight. In fact, I think it should look more like this. So let's go ahead. Is this the only plane that behaved this way?
This is a cool app called planefinder.net, and I've added on a filter, and it's just showing some of the largest airplanes right now. These are actually airplanes that are in the sky as we speak. It's a Saturday night, about 10 p.m., and you can see all of these planes are Boeing 777s. And if I want to, I can actually zoom up and click on one to see its flight path. So if I go here and click on this one, it will show me the flight path for that plane. Here, I'll close this to get that out of the way. Oops, no, I actually want to click on that. So anyways, you can see a part of it to the side. I can see the whole thing. This is a British Airways flight that is going from Seattle, Washington to London Heathrow. London's around here, and if you look at it, it seems to be doing an arc here. So it's going over Greenland. You would think it would just go straight from Washington across. Let's see if some other planes are doing. This one, ooh, there's a FedEx plane. Oh, it looks like they're starting up in Greenland. Here's an Air Canada that's going to France. So it's heading, it doesn't even look like it's going in the right direction. It seems to be heading north. France is over here. So we're going to take a look at the geometry and see why are these planes going in such interesting directions. Let me zoom in on this other airplane here. This one started out in JFK, which is in New York. And you can see, here's the arc. It went north of Canada, and it's heading towards Peking, China. All right, China's over here. And it's going to be going over Alaska. It has gone over Alaska all the way to here. Not exactly the route I would predict. And we're going to try and explore why this is the case.
So after looking at the path of other airplanes on planefinder.net, what do you notice about their flight paths? So first of all, you probably noticed they didn't take straight lines, at least not as we thought. So what does it mean for a line to be straight? A line is straight if it takes the shortest path, if it marks the shortest path between any 2 points on that line. So did we draw the shortest path? Well, yes, on flat paper we did. Straight lines on flat surfaces, and that we call those planes, not necessarily airplanes, but planes like a planar surface. Those are what we naturally think of as straight. But what about spheres?
Okay, I'm using a cheap plastic inflatable globe to simulate a sphere. It's not a perfect sphere, but it'll do for our purposes. So we're looking at lines on the globe. Are there any straight lines on the globe? And if you look at it, there are two types of lines. There are longitudes, which go north to south or south to north. They meet at the North Pole and they meet at the South Pole, all right? And then there are also latitudes. Latitudes go east to west or west to east. And if you were looking kind of at it in a sort of a map-like view, you might say, yeah, definitely those latitudes look straight, but look at those longitudes. They're kind of bendy. I don't think the longitudes are straight. So let's start first. We're going to start with the longitudes, all right? So how do I know if a line's straight? Well, one of the easiest ways in flat geometry is we say it's the shortest path between 2 points. So if I have a point here and a point here, If I want to take the shortest path, I can just use string, right? You can see if I pull it taut, that shows me a straight line. So since string is all bendy and flexible, it's a good choice to test on a globe, on a sphere. All right, so let's go ahead and take 2 points on this sphere and say we start here and we'll go all the way down here. When I pull that taut, what do you see? It lines up perfectly with the longitude. This should work on any 2 points on a longitude on the Earth. See how it's pulling straight? Even though I have the string bending over a curvy surface, it is taking the straightest line between those 2 points. So yes, all longitudes are straight lines, which is kind of weird when you think they meet up there and down there. And we'll talk about that more in a little bit. Now we're going to take a look at latitudes, which are these lines going east to west. So first of all, let's start with the most popular latitude of them all, the equator. I'm going to go ahead and start here, say at the Galapagos Islands, and let's go all the way almost to Africa. So I'm going to put a point here and see if my string hugs the equator. It does. The equator is a straight line. All right. Now let's go up north. Remember that flight we were looking at? Let's start in California, somewhere around there. I'll just start right there. And I'm going to stay on the same latitude. So same latitude in Spain, but I'm going to pull the string taut. Wait a second. That is not on the latitude. It's actually going up north. Doesn't that kind of remind you of the flight paths that we were seeing on the Plane Finder application? Now the interesting thing, so now we know why these airplanes are going on these curvy paths. They're taking the shortest distance so they can save fuel. The other interesting thing about these paths, even this one's not a longitude, this is just a straight line on the globe, is if you look at it, it's basically going to cut the sphere in half and create what's called a great circle. The equator cuts the sphere in half and creates a great circle, and so do the longitudes. Any longitude is cutting the sphere perfectly in half, creating a great circle. One last thing on the latitudes, if you look from the North Pole on my kind of wonky sphere globe here, you also see that when you look from the north, these latitudes don't look so straight anymore. And in fact, we've discovered there's only one straight latitude, and that is the equator.
So what did we discover to be true about all longitudes, but not all latitudes? Longitudes, every single one, was on a great circle. It cut the Earth in half. The equator is the only latitude that cuts the Earth in half. You can see it right here. So that's the only one that counts as a straight line on spherical geometry. There are no parallel lines in spherical geometry because, well, first of all, the straightest lines are on these great circles. This is a great circle here, which always cuts a sphere in half, all right? And if I put another straight line, so I'm going to add a straight line as a great circle. So let me just do a great circle there. You can see that that one's also trying to cut the sphere in half. Well, if you have two different lines that are cutting the sphere in half, they will eventually intersect. No matter where I put these points, if I try to move this point, it's always going to intersect. Well, if lines intersect, they can't be parallel. So, as crazy as it is, there are no parallel lines in spherical geometry. Now, this is a Google Earth great app, and this is showing the longest straight line you can sail on the Earth. So here, we are sailing across the Pacific. So we'll start on this end. Here's Russia going straight across the Pacific, and in between South America and Antarctica, up near Africa, all the way to Pakistan. So you can see that was a straight line. The ship did not have to turn. But when you flatten this out into a map, what happens to that line? It looks really crazy. Look at that. That does not look like a straight line when you try to take a spherical straight line and put it into a flat planar straight line.